Hi Pre-Calc students! In this video we're going to talk about a different unit to use to measure angles. So you're used to measuring angles in degrees. If I gave you this angle, you would say that's about 90 degrees. So you know one way to measure angles. Today I'm going to just give you a different unit. So instead of measuring in degrees and saying that this is 90 degrees, you're going to measure in something called radians, and you'll tell me this is blah radians. So you can think about it as, say, we measure distance if you're in the US, you might measure distance in meters or in yards. If you're in any other country in the world, you're going to measure it in meters. It's just two different measurements for the same type of thing. So in that case, it was distance. In this case, it was angles. So let's go ahead and get started. So we're going to be measuring angles today. The old way is measuring in degrees. So if you're trying to make your way around an entire circle, a full rotation, you should know that that's 360 degrees. If we're measuring in radians in our new way, then we say a full rotation is 2 pi radians. And later we'll see why we choose a full circle to be 2 pi. But for now, just think about it as 360 degrees is a circle, 2 pi is a circle. So this might be your conversion, like 3 feet is approximately 1 meter. So we're just thinking about it as a conversion. So how does this help us to measure angles? So let's look at theta 1. I drew it in a little bit of a misleading way, but I wanted to draw it so that it's about 1/8 of the circle. So if we separate all of the degrees of the circle into eighths, well, then 1/8 is 45 degrees. This is a 45-degree angle. In radians, if we take our full circle and we separate that into 8 parts, well, then this same angle could be called pi over 4 radians. So 45 degrees is the same as pi over 4 radians because 360 degrees is the same as 2 pi radians. So let's do another one. Here's our right angle from before. We separate our 360 degrees into 4 equal parts. 1, 2, 3, 4. And so 360 divided into 4 parts is 90 degrees. And so that pink angle, theta 2, is 90 degrees. If we do it in radians, then our whole circle is 2 pi, and I'm dividing it into 4 parts, 1, 2, 3, 4. So one of those 4 parts measures 2 pi over 4 radians, which is just pi over 2 radians. This tells us 90 degrees is like pi over 2 radians. In our last example, we go all the way around to make a straight line. So what is a straight line worth of degrees? Well, that's 180 degrees. It's half of the circle. So in radians, if we divide our circle into 2 equal parts, that's pi radians. So we have that 45 degrees is the same as pi over 4 radians, 90 degrees is the same as pi over 2 measured in radians, and 180 degrees is the same as pi radians. So this angle is pi, this angle is pi over 2, and this angle is pi over 4. So the next thing we want to be able to do with this is to convert back and forth between radians and degrees in a systematic way where we might not necessarily have the picture. Maybe all we have is some numbers. So let's go ahead and do that. So again, our main tool is just that 360 degrees is the same as 2 pi radians. And let's say I want to find what 45 degrees is in radians. My first method is to use ratios. So if I want to know what 45 degrees is, in radians I can say, well, 45 is to 360 as blank is to 2 pi. So what the ratio method says is take the part in degrees and divide that by the whole in degrees. And that's going to equal the part in radians divided by the whole in radians. So now I just have to solve this ratio. So I do that. I usually solve ratios like this by cross multiplying. So this says 45 times 2 pi, which is 90 pi, equals 360 times x. Now I'll divide both sides by 360. 90 over 360 and reduces to 1 over 4, so I get pi over 4 equals x. So my answer is 45 degrees equals pi over 4 radians. So that's the ratio method. There's also a formula that we can use. The number of radians equals the number of degrees times pi divided by 180. So let's try this. The number of radians equals the number of degrees, which in this case is 45, times pi divided by 180. 45 goes into 180 4 times, so this reduces to pi over 4, which is what we got above. So 2 methods for going from degrees to radians. Let's say we want to go back in the other direction if I'm given radians and I want to find the number of degrees. So let's say my angle measures pi over 6 radians. How many degrees is that? How big is this angle? That's what I want to know. So let's use the ratio again. So I'm going to have the part over the whole equals the part over the whole. And here, the part, I'll have either degrees and radians, or the other way around. So let's say the part in degrees divided by the whole in degrees is going to have the same ratio as the part in radians divided by the whole in radians. So by the part, I just mean the angle I'm interested in. By the whole, I mean the circle. And so if I plug this in, the part in degrees is what I'm looking for. So that will be my x. The whole in degrees is the full circle. So that's 360. The part in radians is my angle, so that's pi over 6. And the whole in radians is my full circle, so that's 2 pi. So now I just solve this for x again by cross multiplication. So I get 2 times pi times x equals pi over 6 times 360. So I'll have the pi's on each side cancel each other out. So then I'm left with 2x equals 360 divided by 6 is just 60. So now I divide both sides by 2, and this tells me that x equals 30 degrees. So pi over 6 radians is the same as 30 degrees. So it's about this big. And we have a formula going in this direction as well. The number of degrees is 180 times the number of radians divided by pi. So I could solve the same question using the formula. The number of degrees is what I'm looking for. So that's going to be 180 times the number of radians. The number of radians is pi over 6 divided by pi. So 180 pi divided by 6 over pi. 180 divided by 6, well, that's just 30, so I have 30 pi on top. Divide by pi on the bottom, the pi's cancel, so I get 30 degrees, just like I expected. So come back to these examples as you're trying to convert between degrees and radians and see how you do. Good luck!